And welcome everybody to the Daily Space Weather Show. Running a little bit late, so we're going to be at a high pace once again today. We've got 2 more coronal mass ejections headed toward Earth. We'll cover it and lots more. We've also got 2 more massive active regions rising there in the east. Also some sunspots forming rapidly in the southwest. So there's the equatorial zoom. We're looking at 171 plus 193 60-minute running difference from SDO. And as the likelihood of a large solar flare in the southwest evaporates, we see large solar flare likelihood in the southeast instead. So there is what's still visible of the filaments supported by sunspot 3599. But we've got a new interesting couple of places to look. So we already see sunspots rising there over the northeastern limb. Quite a large area of magnetic organization happening up there. But the most active region is one that's not even yet visible. So that's looking like a pretty berserk sunspot there, likely beta gamma delta class. So we saw some M-class flaring activity happening down there. We'll get to it and plenty more today on the Daily Space Weather Show. So there is that's today, March 16th, colorized magnetogram plus 171 angstroms once again. Let's take a brief look at what's going on Earth. We've got erupting volcanoes, and here is the list from volcanodiscovery.com. Sakurajima, Merapi, Dakono, Popocatépetl, Sanchaguido, Fuego, Nevado de Ruiz, Revenador, and Sabancaya. As far as earthquake activity goes, there are the past 90 days, and the earthquake drought continues, folks. 7 magnitude earthquake drought. So those end in large earthquakes, and it's been quite a while since late January that we saw a 7+ magnitude, and it was barely a 7+ magnitude quake. Let's see what's been shaken for the past 24. These are the 5 and greater magnitude quakes. A 5.5 in the southern ocean there, north of Antarctica, happened early this morning. Also a 5.2 at Papua New Guinea. We do have one quake of concern here. It's not this one. Off the coast of Mexico or near the coast of Mexico, that 5.0 at 13:56 this afternoon. But we have a lot of quakes here around the North American plate boundary. Check it out. Around the North American Pacific plate boundary, seeing significant quakes there. So that could bring a quake. But here's the most interesting one, this 5.3 that's located pretty close to Fukushima. And everybody knows how historic of an area that is for large earthquakes. There's the historic information, and that is indeed a very active zone for large quakes. So hopefully that's not a foreshock. And let's get back to some space weather stats. The 10.7 centimeter radial flux has rapidly risen to 144 solar flux units with those new active regions in the east. So that'll be updated 144. 144 solar flux units is the current 10.7 centimeter radial flux. NOAA's not forecasting any geomagnetic storms or geomagnetic unrest, but we're going to have some now because we've got 2 legit CMEs headed toward Earth. So they'll show up sometime late in the day on the 19th. March 19th is going to be geomagnetic storm time as 2 CMEs are headed this way. Next, we'll take a look at Earth's magnetic moment from space. We'll get more into the CMEs and we'll show you those. There are the past 4 hours of Earth's magnetic moment from space, our geospace magnetosphere movie. So that's what's been going on out to about 12 Earth diameters. Very weak solar wind. So here are the last 4 hours of Earth's magnetic moment from the ground, showing magnetic flux density at the ground level. Also the last 4 hours, also part of the space weather modeling framework. Again, it depicts magnetic flux density at the ground level, and you can use it to see auroras when things are a little bit more interesting geomagnetically speaking. KP 0.33, so very low solar wind here for the past 24 hours. Not even making it to KP1, just to KP1 there for 3 hours. So, and for you new viewers, the KP index is an average of global geomagnetism from the Space Weather Prediction Center. Next solar wind at the ACE. And we've got some missing data there at the tail end, so let's just show that. There you go. That's the ACE, located at Lagrangian point 1, and here is the Discover. So it looks like, all right, maybe that, no, I think they're both missing data there, so it could be some communications errors. Discover showing about 5.5 protons per cubic centimeter for the density, and the velocity here 433 kilometers per second, having ramped down from more like 480. So it looks like a minor CME impact there. Not a lot of deflection in the magnetic field at all, so not very exciting. It's weak space weather. Next is our GOES magnetometer data, or next are our GOES magnetometer data, I guess I should say, to be grammatically correct, and a little bit higher highs and higher lows in the past 24 hours, as measured by the GOES 16 and GOES 18. Next, our magnetic sector. Has Earth snapped into a South Pole sector yet? Well, the answer is it's close. It'll be coming before tomorrow's daily space weather video. So there you can see the last image. Earth's potential field surface source line there, shown in orange, is only maybe 10 hours from snapping into a South Pole-oriented magnetic sector. Here's our line of sight field plot depicting the solar B field in blue. The potential field surface source lines in red and green are south and north respectively. The grayscale portion is the photosphere magnetism, the layer of the sun where we see sunspots. So that's the past 4 days, and that's a lot of information crammed into a series of 110 frames. Next is coronal hole line of sight field plot. And we've got South Pole-oriented coronal holes rotating in. And let's take a look at those from SDO. Let's take a look at those from SDO's perspective. So there you go. Those easterly sunspots, which would be to your screen left, those are South Pole orientation, leading those two new likely massive sunspot groups, especially the southeastern one, again, which has produced some flares. And before we get to sunspots, let's take a look at sunspot number here. Rose a little bit, and it's going to rise a lot before tomorrow's daily space weather video. We may see as many as 50 new sunspots counted in the next 24 hours. So let's take a look at that rapid growth there in the southwestern quadrant. Also some growth in the northwestern quadrant and then the north central quadrant. That's not a quadrant, I guess. The north central area. So that's what's going on, and let's look at flares and things. And we've got a bad gateway, so we'll ignore that. So solar energetic particles are now ramping down below warning levels. So you'll get a little bit less radiation if you do happen to have a polar flight at this point. So yeah, proton flux here ramping back down. So no new events here, well, because the action isn't in the right place to make it likely to see proton events. So, but 2 M-class events have happened in the past 24 hours, including an about an M3.5, an M3.5, and then another smaller M1 class solar flare. So that's the flare scenario. And let's once again take a look at some SDO data. Here is the splentacular 304 angstroms. Not 304, 94 angstroms. That's what it is. That bright green color represents ionized iron. So let's zoom in a little bit. What the heck? I can't scroll over? What's up with that? What's up with that? All right, well, there you go. There's our T-mass. Today's most active sunspot is a sunspot that's not even countable yet as a sunspot. So again, that's probably quite a large sunspot group, or at least a magnetically complex one. Based on the flare, flare production, it's likely a beta gamma delta class. Also, if you notice in yesterday's video, called it, as we said, the likelihood of an Earth-directed CME is very, very high, and we'll show that here in a moment. First, let's take a look at a star chart to orient ourselves before we think about plasma flying through the solar system, shall we? So this is what's going on over our head. That's our star chart from skyandtelescope.org. The sun is in ascending mode. Here's our solar system forecast. Here's where things will be in a week as we approach the March full moon. And guess what, folks? There are some CMEs that are headed in this direction. This direction. From sun to Earth. Remember, folks, there's a cone that goes between Earth's ionosphere and the sun. That is space weather. From the D layer of the ionosphere to the photosphere of the closest star. That is where space weather occurs. Every place else, not really space weather. Just in case you weren't aware of that, I figured I'd share that with you. Next, the Extremely Large Telescope, or ELT, located in the Atacama Desert of Chile. That is the astronomy photo of the day. And of course, in this imagery, you can see the Large and Small Magellanic Clouds. So here's the Large Magellanic Cloud. Down here is the Small Magellanic Cloud. They are satellite galaxies of the Milky Way. They are dwarf galaxies that are gravitationally bound to the Milky Way galaxy. Anyway, there it is, apod.nasa.gov. And let's move on to some CME action. Yeah, CME action. There are two headed toward Earth, pretty much directly toward Earth. And it might not be evident on that imagery, but worry not. We've got some synced up imagery for you. Not that. Who cares about that? That ain't no thing. This is what I'm talking about. And no, I don't know why the Earth scale is there. I definitely didn't put it there. I put the Earth scale up here. But sometimes there are errors, folks. Sometimes there are errors that are not user errors. So, anyway, let's move on to our next. There we go. We're zoomed in a little bit more, and you can see some big plasma motions right in the center of the solar disk. There's one up here, and then there's one right down here. Those are two earthly directed CMEs. So, again, expecting geomagnetic storm conditions up to as much as KP 6.33 sometime later in the day on the 19th. Possibly as early as midday on the 19th, but more likely sometime later in the day. They don't look like they're particularly high speed to me, but it's a little bit hard to tell when a thing is moving directly toward you. So this will show you even more plasma filament motion. Look right in the center of the solar disk and you see two Hyder flares happening there. That is the secondary flare as plasma splashes back down toward the chromosphere. And yeah, so again, right up here and right down here are two CMEs. Now the second one that's farther to the south, that will not be as strong of a hit as the northern one, but that northern one is directly earthly directed. It's it's pretty much oriented right toward Earth. The southern one not as much. Keep in mind those are theoretically able to become co-rotating regions, so they could interact with each other depending on their relative velocities and so on. So anyway, there's an even closer look. And it's time to move on to filaments. So let's get that off the screen and those bad gateways, and look at those filaments. Now you're going to see some of those disappear because they are headed toward your back door. What the heck? What is up with that? Looks like there's missing data there. I don't know what's up with it. We do have some prominences here, but let's move on to the colorized. There we go. And you're going to see some of these filaments. Whoops! You see how many of them are now missing. So that is because they are now blasting through the solar system at several hundred kilometers per second. These are the facts, Jack. So here are the past couple of hours, and we got to pick this thing up because we are running massively late. So pardon the speed, but let's step on the gas. Bonus features are next. Satellite charging hazards are non-existent. GOES electron flux here is in a normal operating range. That's nominal electron flux. Not too high, not too low. There's the past year from Solon.info, and there's the forecast model. You can see NOAA was off by a little bit and expecting relatively flat levels over the coming 3 days. Next, we'll show the layer where it's measured the ionosphere. It's the F layer. The F layer. So the bridge between Earth and space is kind of the D layer of the ionosphere, but anyway, here's the F layer. It's located at 300 kilometers of altitude or so. That is depicting megahertz, or millions of vibrations per second. Who remembers when we used to measure computer clock speeds in megahertz? Remember that? That was fun in the late 1980s. I had one that was like 10 megahertz. Anyway, here is the anomalygram, and space weather has been mild, so a lot of blue on that map. Those are high-frequency anomalies, which are more common when space weather is slow, which it is, very slow, like the solar wind. So that's what's going on, and let's get through the rest of our bonus features here so we can do meteorology. There is our Global Ionosphere Nowcast, depicting total electron content on the left, and maximum usable radio frequency on the right. So check it out. There's that new sunspot. It is quite large. This group down here is looking very promising for additional large solar flares. So do we see any umbrae yet? Not down there, but up here we certainly do. So that's what's going on. And let's get to meteorology. So we throw in the meteorology segments just for fun because, well, forecasting the Earth weather is way too easy. It's not challenging at all, folks, to forecast your weather extremely precisely for your specific location. If you understand the physics and you have the data access, you can forecast your weather, folks. It's super easy, super easy. Anyway, here's the coldest place in the world. That is Antarctica. Antarctica in the summertime has areas that are negative 60 degrees Fahrenheit. A lot colder than Greenland in the winter, in fact. So that's what to expect if you ever go to Antarctica. You'll probably go in the summertime. But anyway, let's move on to meteorology. There are surface winds of the east, and we got several lows there in the Pacific. Check it out. Lots of lows in the Pacific. There are the jet streams to the central world. And congratulations to Jasper Philipsen for winning the Milan-San Remo, the longest of the one-day classics and the first major monument of the year. Here are the surface winds of the central world. There are the surface winds of the west. And there are the jet streams. We've got a tripled up jet stream over parts of North America and a huge bend here, some frigid air. Not the refrigerators. The cold air from Canada moving down toward the Great Lakes. Next is our satellite map. There you go. Some rapid cloud nucleation happening once again in Brazil. But there's a satellite view. Fantastic. Next is our snow depth map, and if you're planning on breaking out some spring powder, well, it's still wintertime, but there is quite a bit of snow to be enjoyed in the U.S. Also, what an enjoyable end to winter, folks. It was like 60 degrees here in Pennsylvania today, and it was just splentacular. Splentacular. So yeah, only less than 4 days until spring. Next, our weather.gov map. We'll briefly scroll down to show you the key, and then we'll scroll back up to show you that map. If your location's lit, head to weather.gov and get your location bulletin from the National Weather Service. And we'd show some forecast models, but it's been down. So, okay, it's back. We're going to show you pressure and precipitation, and that's it. That's all you get, folks. So it was down. Now it's up. There you go. There's our pressure and precipitation map based on a 72-hour GFS model. A little bit more snow there coming to the southern portion of the Rockies. And next, our lightning maps. There's about the last 10 hours. Texas had quite a bit of lightning. Also, Louisiana and Arkansas had a taste. And do we have any current terrestrial strikes? Well, let's find out. Indeed we do. Texas is currently the lightning capital. And there is thunder rolling in to Waco. Waco. If you enjoy the content, press the like button. If you are new to the channel, press the subscribe button. You wouldn't want to miss the most comprehensive daily space weather in the world, would you? We also provide the most detailed solar imagery, so yeah, press like, visit our links, help out the channel, and never try to sneak up on a dragon in its own lair. It is the year of the dragon, after all, so cheers. Anyway, we got a massive system here southeast of Anchorage. A very strong low, likely associated with that precipitation, but we're going to focus on the lower 48. Again, frigid air coming in from Winnipeg down to Minneapolis and Milwaukee. It's a cold snap. Not to be confused with Sam Adams' cold snap. I'm talking about cold air. Anyway, here's a satellite map. And there is the water vapor map. When your Doppler is unclear, try the water vapor map. If you understand atmospheric physics, you'll be able to forecast your weather. Anyway, here's a recap. U.S. Doppler radar, satellite, and there is the water vapor. And here's me closing out. Thanks for tuning in the meantime. Until tomorrow, may that solar wind be at your back. I'm going back to the bunker.